A machine that costs less to rent for one day than a single trip from a concrete truck can turn soft, shifting dirt into ground solid enough to carry a shed, a patio, or a fence line for decades. And it does it without a single bag of cement. No mixer, no forms, no 3-day cure time. Just sound and motion, applied at exactly the right pitch. Stick with me, because by the end of this you'll understand why the ground under your own yard might already be more capable than you've been told. Here's the problem almost every homeowner runs into. You want to put something on your property, a shed, a gravel patio, a post for a fence, and the ground underneath is loose, sandy, soft. It shifts when you step on it. So you call around, and every contractor tells you the same thing. Pour a slab. Suddenly, a simple backyard project turns into a quote for over $1,000, sometimes several thousand, plus a delivery truck blocking your driveway and days of waiting for the concrete to cure before you can even build on it. It works, sure. But it's slow, it's expensive, and for a huge number of small projects, it's overkill for what the ground actually needs. What almost nobody realizes is that loose, granular soil isn't broken. It's just disorganized. The sand and gravel particles under your feet are sitting in a loose, random jumble, held apart by friction and full of tiny air pockets. Those pockets are exactly why the ground feels soft and why it settles under weight. But that same soil, rearranged into a tighter pattern, can become dense enough to bear real structural load. No additive required. The material you need was already there the whole time. It just needed to be organized. This isn't a new idea. It goes back to engineers in Germany in the 1930s who were wrestling with exactly this problem on a much bigger scale. Ports, dams, and warehouses being built on loose, sandy ground that kept settling under the weight of what was built on top of it. Two of them, working with vibrating equipment, noticed something strange. When they drove a vibrating probe into loose sand at just the right speed, the sand didn't scatter. It tightened. The individual grains seemed to briefly lose their grip on each other and then lock into a denser arrangement once gravity pulled them back down. They patented the method, and within a couple of decades, it had made its way into serious infrastructure work, including projects overseen by U.S. engineers on dam foundations in the late 1940s. It wasn't a gimmick. It was documented, tested, and used on projects where failure meant a dam giving way. So why does the frequency matter so much? Every kind of soil has what's called a natural resonant frequency, basically the exact rate of vibration that soil wants to move at, the same way a wine glass has a pitch that makes it hum if you hit the right note. For loose sand, that frequency tends to fall somewhere in the range of a slow mechanical shake, not much faster than a washing machine on spin cycle. When you vibrate the soil at that specific rate instead of just randomly shaking it, the energy transfers with far more efficiency. The friction between grains drops for a brief moment, the particles behave almost like a thick liquid, and they settle into the tightest, lowest energy arrangement available to them, squeezing out the air pockets that were making the ground weak in the first place. Once the vibration stops, the particles are locked into that denser structure, and they don't just drift back apart on their own. Geotechnical studies going back decades have measured meaningful, lasting increases in soil density and load-bearing capacity from this kind of treatment, and follow-up testing on treated sites years later shows the density holding. If this is real, documented science, why isn't it common knowledge for homeowners? Mostly because of how the construction industry is set up to make money. Concrete is a product. It can be manufactured, delivered, branded, and invoiced. A contractor can build a business model around selling you bags of mix, a truck, and a crew. Compacted soil, on the other hand, isn't really a product in that sense. You can't put a markup on gravity finding its own equilibrium. So the entire supply chain, building material stores, contractor training, even a lot of home improvement content, defaults to concrete as the answer before anyone even asks whether the ground could handle the job with a lot less material. It's not some grand secret. It's just that nobody in that chain has an incentive to walk you through the cheaper option. This technique is already standard practice in professional geotechnical engineering. It's used to prepare ground under highways, industrial buildings, and yes, dam foundations, under the name vibrocompaction or vibratory ground improvement. Engineers use cone penetration testing before and after treatment to measure exactly how much the soil's strength improved, and the before. And after numbers are dramatic enough that it's a standard tool in the industry's toolbox, not a fringe trick. The consumer version of that same principle is the plate compactor you can rent from almost any equipment rental counter in the country. So here's how you'd actually put this to work on a small, unpermitted project like a shed pad, a gravel patio, or a fence post base. Start by checking your soil type. This method shines on sandy, gravelly, or mixed granular ground, and it struggles on heavy clay or anything with a lot of organic material like topsoil or peat. So know what you're working with first. Clear the area down to bare mineral soil, removing grass, roots, and debris. If the ground is bone dry, lightly dampen it. A bit of moisture helps the particles slide into place during compaction and then drains away, leaving the tighter structure behind. Rent a reversible plate compactor, rated for a few thousand pounds of compaction force. Most rental yards carry them for well under $100 a day. Walk it slowly across the area in overlapping passes, then run a second set of passes perpendicular to the first so you don't leave gaps in coverage. On the right soil, you'll actually feel and see the ground firm up under the machine within a few passes. For a shed pad or patio base, top the compacted native soil with several inches of angular crushed gravel and compact that layer the same way. Angular stone locks together far more effectively than smooth river rock. The total cost usually lands in the low hundreds of dollars, a fraction of what a poured slab would run. Now, the honest limitations, because this isn't a universal fix. Clay-heavy soil doesn't respond well to vibration. The particles are too fine and cohesive to rearrange this way, so you'd need a different approach entirely. Organic soil like topsoil or peat will keep compressing under load no matter how much you vibrate it, so it needs to be excavated and replaced, not compacted. And for anything that actually requires a permit or engineering sign-off, in addition to your house, a load-bearing structure, anything your local code officials need to inspect, you follow the code and get proper engineering, full stop. This method earns its place in the huge category of small, lightly regulated backyard projects, not as a substitute for professional structural engineering. At the end of the day, this isn't about tearing down concrete or pretending it's useless. Concrete absolutely has its place. It's about understanding that the ground you're standing on is more capable than the default answer usually gives it credit for, and that sometimes the smartest fix isn't the one that gets marketed to you the loudest. If you found this useful, that's exactly what Hidden Fix Lab is here for. Digging up the practical knowledge that never quite made it into the mainstream conversation.